Hi everyone and welcome back to my channel. Today we're diving into logarithms. I know logarithms can sound like one of those tricky math topics, but trust me, by the end of this video, you'll see just how easy they can be. We'll explore the basics of logarithms in this video. So whether you're here to ace your next test or just want to level up your fat brain, you're in the right path. Ready to unravel the mystery of logs? Let's get started. So the logarithm of x to the base b is the exponent of b that gives x. So if you see this notation, this is asking you the exponent at which b should be raised to produce an x. We are restricting here that the b and x are positive and b is not equal to 1. For example, logarithm of 8 to the base 2 is asking you the exponent of 2 so that the answer is 8. What should be the exponent of 2 so that the answer is 8? So the answer is 3 because 2 cubed is 8. Another example, logarithm of 25 to the base 5 is what? That is asking you the exponent at which 5 should be raised to get 25. So what should be the exponent of 5 to get a 25? So the answer is 2. So the exponent of 5 to get a 25 is 2 because 5 squared is 25. Example number 3. Logarithm of the square root of 7 to the base 7 is what? What should be the exponent of 7 to get a square root of 7? Okay, easy. That is 1/2. Because square root of 7, that is in radical form. If you transform that to exponential form, that is 7 raised to 1/2. This one is 7 raised to 1/2. Okay, for the radicals, that is for square root, that is exponent 1/2. So what should be the exponent of 7 to get 7 raised to 1/2? Of course, the answer is 1/2. Take note, if it's square root, that's 1/2, exponent 1/2. If it's cube root, that's exponent 1/3. If it's fourth root, it's exponent 1/4. And if it's nth root, that is exponent 1/n. How about this fourth example? Logarithm of 81 to the base 3 is asking us the exponent of 3 so that the answer is 81. So the answer is 4 because 3 raised to 4 is 3 times 3 times 3 times 3. That is 81. So the exponent should be 4. How about this one? The logarithm of 1/6 to the base 6. So what should be the exponent of 6 to get 1/6? The answer is -1. Because in the laws of exponents, if you have a negative answer, you take the reciprocal of the base so that the exponent will be positive. So 1/6 is actually 6 raised to -1. So the exponent that 6 should be raised to get 6 raised to -1 is of course -1. Logarithm of 1 to the base 8. What should be the exponent of 8 to get a 1? Of course, the answer is 0 because if you have a non-zero number raised to 0, the answer is always 1. So the exponent is 0. Example number 7. 8 over 20. Logarithm of 8 over 27 to the base 2/3 is what? What should be the exponent of 2/3 to get 8 over 27? The answer is 3. So I hope by now you already know how to identify or to evaluate logarithmic expressions, okay? It's just asking you the exponent at which the base here should be raised to get the bigger one here. Number 8, what should be the exponent of 7 to get 1 over 49? That is logarithm of 1 over 49 to the base 7. Answer is -2. Because 1 over 49 is 7 raised to -2. So in this lesson, in logarithms, you should be familiar with your laws of exponents and the different powers of numbers. Okay, logarithm of 4 to the base 1/4 is -1. Negative 1/4 should be raised to -1 to produce 4. Number 10. Logarithm of 25/4 to the base 2/5 is, okay, if you just raise 2/5 to 2, that will give you 4/25. But this one is the reciprocal of 4/25, so you take the negative of the exponent. So it should be -2. Okay, so this time having 10 examples. I hope that you're ready to answer some exercises. I hope that you already understand the meaning of the logarithm of a number to a certain base. We still have example number 11. If there is no base written, that is understood to be base 10. The base is 10 if there is no base written. That is what we call common logarithms. Okay, what should be the exponent of 10 to get a 10? Answer, 1. Okay, so if you don't see any base there, the base is 10. So the logarithm of 10 is 1. Number 12, logarithm of 0.1, still base 10. What should be the exponent of 10 to get 0.1? 0.1 is actually 1/10. So 1/10. So that is the reciprocal of 10. So that is actually 10 raised to -1. So what should be the exponent of 10 to get 10 raised to -1? Of course, -1. 13, ln of e squared. Ln is the natural logarithm, that is logarithm to the base e. So if you have ln of, let's say for example, x, that means you're asking for the logarithm of x to the base e, where e is approximately 2.7. That is the natural number e. Okay, so if we write ln, that means to say that is the logarithm to the base e. So what should be the exponent of e to get e squared? Of course, 2. Another one, number 14, ln of 1/e. 1/e is e raised to -1. So -1. Number 15, ln of 1. That is logarithm of 1 to the base e. What should be the exponent of e to get a 1? Answer is 0. Okay, so we also have here the basic properties of logarithms. As what you can see, if we have logarithm of 1, the answer is always 0 if we just have a valid base b. And then the logarithm of b raised to x to the base b is x. We also have several examples like this. So the exponent there is going to be the answer. And then by the definition of the logarithm of x to the base b, logarithm of x to the base b is the exponent at which b should be raised to produce x. So b raised to the logarithm of x to the base b is actually x. Okay, for example, we have logarithm of 1 to the base 2 is 0 because logarithm of 1 is always 0. Logarithm of 1 to the base 10 is also 0, and logarithm of 1 to the base e is also 0. So logarithm of 1 is always 0. And then logarithm of 2 raised to 7 to the base 2 is 7. So whatever the exponent there will be the answer. Logarithm of 5 raised to -3 to the base 5 is -3. And ln of e raised to 1/3 is 1/3. 4 raised to logarithm of 16 to the base 4 is 16. That is by applying property number 3. 6 raised to the logarithm of 2 to the base 6 is 2. And e raised to ln 3 is 3. So those are the examples of applying the basic properties of logarithms. Okay, try the following exercises. Number 1, you have logarithm of 16 to the base 2. What should be the exponent of 2 to get 16? Number 2, logarithm of 27 to the base 3. Number 3, logarithm of 1/9 to the base 9. You can answer all of these. You can pause the video and answer all of the items. Number 4, logarithm of 1/36 to the base 6. Number 5, logarithm of the square root of 5 to the base 5. By the way, thank you so much for those who are always watching the video. Okay, so this video is really meant for you, students, so that you will have an option in your studies. That after your teacher teaches you in your class, you can also watch the video so that you can learn by yourself, or you can reinforce or enrich what you learned in your school. Number 6, logarithm of 4 to the base 1/2. Number 7, logarithm of 32 to the base 2. Number 8, logarithm of 4/9 to the base 2/3. Number 10, logarithm of 1000. No base means the base is 10. Number 10, ln e. ln means logarithm to the base e. Number 11, logarithm of 1 to the base 7. Number 12, logarithm of 2 raised to negative 8 to the base 2. Number 13, 3 raised to the logarithm of 9 to the base 3. 14, logarithm of 1/3 raised to 5 to the base 1/3. And number 15, e raised to ln 12. So for numbers 11 to 15, you apply here the basic properties of logarithms. Okay, so pause the video if you need more time, but if you're done, let us answer. Number 1, exponent of 2 to get 16, 4. Number 2, 3. Number 3, negative 1. Number 4, negative 2. Number 5, 1/2. Number 6, negative 2. Number 7, 5. Number 8, 2. Number 9, 3. And number 10, 1. Let's proceed. Number 11, logarithm of 1 is always 0. Number 12, negative 8. Number 13, 9. And number 14, 5. And number 15, 12. Count your score, and you can comment down below your score so that I will know if you got perfect or not. And if I will also know if you know how to evaluate logarithmic expressions. Okay, so I hope that you have a nice experience in answering these exercises. Okay, let us also have the change of base formula, because sometimes the answers will be fractions and they might look at first difficult, but actually they're not really that difficult. Okay, the change of base formula, we can prove this, but in this video, we will just apply this formula. So the logarithm of a to the base b can be expressed as the quotient of logarithm of a and logarithm of b to any possible base c. So we are changing here the base. Instead of base b, we are having a different base. So we will express the logarithm of a to the base b as logarithm of a over logarithm of b. And we can choose any base c. For example, logarithm of 32 to the base 4. At the first look, what should be the exponent of 4 to get 32? It might look a bit challenging, but actually if you will use the change of base formula, it's just easy. So if you will use the change of base formula, that will be logarithm of 32 divided by logarithm of 4. And it's up to you what base you will choose. But in this case, since we have 32 and 4, these are powers of 2, of course we will use base 2. So that logarithm of 32 to the base 2 is 5, and logarithm of 4 to the base 2 is 2. Logarithm of 32 to the base 2 is asking us the exponent of 2 to get 32. Of course, that's 5. And logarithm of 4 to the base 2 is asking us the exponent of 2 to get 4. And that is 2. So the logarithm of 32 to the base 4 is actually 5 halves. Another one. By this time, I think you can already answer this on your own. Pause the video and try this. And let's check if your answer is correct. Okay, we will have that logarithm of 25 over logarithm of 125. And we are free to choose the base. Of course, 25 and 125 are powers of 5, so we will use base 5. Logarithm of 25 to the base 5 is asking us the exponent of 5, so that the answer is 25, and that is 2. And then logarithm of 125 to the base 5 is asking us what should be the exponent of 5 to get 125. The answer is 3, because 5 times 5 times 5 is 125. So, logarithm of 25 to the base 125 is 2/3. Number 3, logarithm of square root of 6 to the base 1 over 36. Of course, we will use base 6 here. So we will have logarithm of square root of 6 to the base 6 over logarithm of 1 over 36 to the base 6. Logarithm of the square root of 6 to the base 6 is 1/2. And logarithm of 1 over 36 to the base 6 is negative 2. 1/2 divided by negative 2 is the same as 1/2 times negative 1/2, which is the reciprocal of negative 2. And that is negative 1/4. So the logarithm of the square root of 6 to the base 1 over 36 is negative 1/4. Number 4, logarithm of 81 to the base 243 is equal to the logarithm of 81 over logarithm of 243. Of course, the base that we're going to use is 3, because 81 and 243 are powers of 3. What should be the exponent of 3 to get 81? That's 4. And the exponent of 3 to get 243 is 5. So logarithm of 81 to the base 243 is 4/5. Number 5, logarithm of 1 over 16 to the base 8. That's logarithm of 1 over 16 over logarithm of 8. So we will choose base 2. So logarithm of 1 over 16 to the base 2 is the exponent of 2 to get 1 over 16. 16 is 2 raised to 4, but 1 over 16 is the reciprocal, so we should have negative 4. So negative 4 over exponent of 2 to get 8, 3. So negative 4 over 3 is negative 4/3. Okay, after the 5 examples, I hope that you can already answer these exercises. Okay, please pause the video if you need more time. We have here logarithm of 1/4 to the base 32. So what base are you going to use there? If your answer is 2, then that's correct. Number 2, logarithm of 64 to the base 256. You can use base 4 or base 2. Number 3, logarithm of 1/8 to the base 1 over 32. Number 4, logarithm of 49 to the base 343. Number 5, logarithm of square root of 5 to the base 625. And number 6, logarithm of 81 to the base 27. So number 1, that's logarithm of 1/4 over logarithm of 32. Choose base 2. Logarithm of 1/4 to the base 2 is negative 2. Logarithm of 32 to the base 2 is 5. So the answer is negative 2/5. Number 2, logarithm of 64 to the base 256 is logarithm of 64 over logarithm of 256. You can choose base 2 or base 4. If you choose base 2, that is 6 over 8. You can simplify that to 3/4. Number 3, logarithm of 1/8 to the base 1 over 32 is logarithm of 1/8 over logarithm of 32. Choose base 2. 1/8 is 2 raised to negative 3, so you will have negative 3. 1 over 32 is 2 raised to negative 5, so negative 5. Negative 3 over negative 5 is positive 3/5. Number 4, logarithm of 49 over logarithm of 343. Use base 7. Logarithm of 49 to the base 7 is 2. Logarithm of 343 to the base 7 is 3. So the answer is 2/3. Logarithm of the square root of 5 to base 625 is logarithm of square root of 5 over logarithm of 625, both base 5. So logarithm of the square root of 5 to the base 5 is 1/2, and logarithm of 625 to the base 5 is 4. 1/2 divided by 4 is the same as 1/2 times 1/4. That is 1/8. And last number, number 6, logarithm of 81 to the base 27 is logarithm of 81 over logarithm of 27. Choose base 3 because they are both powers of 3. 81 is 3 raised to 4, so that's 4 over 27 is 3 cubed, so 3. So 4/3. Okay, that's it for the second set of exercises. If you got 6, congratulations, and you can comment down below what you learned in this lesson and what you can't forget about this video. So thank you so much, everyone. You've tackled the basics of logarithms and hopefully feel a lot more comfortable with them now. Remember, the more you practice, the easier it gets. If you found this video helpful, don't forget to hit that like button and subscribe so you won't miss out on the future math tips and tutorials. And to all my loyal subscribers, thank you for your continued support. You make this channel what it is. If you have any questions, you drop a comment down below and I'll be happy to help. Keep practicing, stay curious, and I'll see you in the next lesson. Bye! Thank you for watching. Comment, like, and subscribe. Bye!